All right, so today we are going to be taking what we've been doing for the last few days, looking at the area of all those different shapes. So parallelograms, trapezoids, triangles, things like that, and basically looking at what are called composite figures, and then finding the area of these composite figures. So a composite figure is two or more basic figures combined to make something new. If you ever have done like tangram puzzles, anything like that, it's like taking these shapes and putting them together to make this picture. So an example of that also would be like right here, and then it's breaking it into those smaller pieces. So you could find the area. Questions to think about: what shapes do you see as you're looking at the figure? It's not always going to be the same for everybody, so it also depends on what kinds of shapes you're most comfortable in finding the areas of, and then using that to kind of break it apart. I'm going to start with kind of this home plate, house on its side shaped figure. There are a couple different ways that we could look at this one. Probably the more basic one that most people would think of doing would be to break it into a rectangle and a triangle. You could do it that way. Another way we could actually do this one is breaking it into two separate trapezoids. Neither way is better than the other. Like I said, it just kind of depends on how you want to look at it. Figuring that most people have an easier time with triangles and rectangles, I'm going to choose to show it that way. But if you wanted to, you could definitely do the area of the two trapezoids as well. All right. To make this easier to follow, I'm also going to use some color. So I'm going to use red to first find the area of my rectangle. So the area of the rectangle in this case is going to be 12 times 16. And in this case, because I am using the rectangle and the triangle, I'm not necessarily going to use 24 as it is, but I'm still going to need it for my triangle. So 12 times 16 ends up being 192. Now I need to find the area of my triangle. I'm going to use blue to just kind of show that. The base of my triangle is going to be this part right here. That's going to be the same as that side of my rectangle, so that's going to be 12. The height of my rectangle, though, is going to be this part right here, which we don't have a measurement for. But because I know that this full length is 24, and at this point it's 16, I can take 24 minus 16 to figure out what is left, which gives my height of my triangle as 8. So I'm going to take 12 times 8, which would be 72, or once again we could do half. And actually for mental math purposes, just to make it's a little bit easier, I'm going to do 1/2 times 12 times 8. So I'm going to do 1/2 of 12, which becomes 6. So 6 times 8 is going to be 48. Now I know the area of my rectangle, the area of my triangle, and I just need to put those together. So I'm going to take 192 and I'm going to add it with 48. So my total area for my composite figure is 240 centimeters squared. All right. Now, I would encourage you to pause the video for this and try this next one and just kind of think through what we just talked about. See if you can figure it out. It's a little bit different because in this case, the composite figure isn't these shapes put together, but it's actually this larger shape with this smaller section cut out of it. And we want to find just the area of the shaded region. So why don't you pause the video, try this out, and then you can follow along and check as you're going. As I look at this composite figure, you could do a couple things. We could break this into two triangles, kind of cutting it down here and then cutting out the rectangle. I'm just going to look at it as one big triangle though. So using colors again, just to kind of help show my thinking. First thing I'm going to do is I'm going to find the area of this whole big triangle. Because they don't give a direct length for the base, I have to put all of these pieces together. So I'm going to have to put 6, 2, and 6 together. So that becomes 14 centimeters. The area of my triangle is going to be the base, which is going to be 14 centimeters times the height. So same thing here, 3 only describes this much, so I have to also add in this side, which is 2. So that's going to be 5. And I could either divide that and multiply those and divide by 2, or I can take a half. I'm going to do half of 14 because that's easier, making that 7. So 7 times 5 is equal to 35 centimeters squared. So that's my triangle. Now I need to take out the area of this square. So the area of my square, because it is a square, is just going to be 2 by 2 or 4 centimeters squared. This time, however, instead of adding, so this was our square, I have to take out the area, which means I end up taking 35 minus 4, which gives us an area of 31 centimeters squared for the shaded region. Now in both of these, I only broke it into 2 figures. As you can see in the example up here though, you can break it into several figures. It just depends on what you see, how complicated the shape is, and things like that. And sometimes you can even take it, this idea of composite figures, and take real examples and then break it into the closest composite figures to find an approximate area, which is kind of cool too. And that's kind of what they do with like lakes and stuff like that.